meeting is being recorded.
Good afternoon, everyone. Thank you for joining us. My name is Marissa Waterman. I'm the Marketing Director here at the Academy. Today's webinar is titled Colorado Springs Utilities, Implementing an Energy Vision. Our Executive Director, Dr. Daniel Uther, will serve as the moderator and will introduce our three speakers today. During the presentation, you'll be able to submit a question by clicking on the Q&A icon on the bottom of your screen. Before we get started, Dr. Uther would like to say a few words. Dan, how are you?
I'm wonderful. Thanks, Marissa. Welcome to everyone who's joining us today. As you know, the Academy offers programs that are often free to our members. The goal of our programs, including these webinars, is to grow, connect, and diversify the environmental profession. And today is a great example of that principle in action. As we begin, I'd like to say a special thanks to our patrons highlighted here on this screen. Patrons are organizations who see a benefit in the work of the Academy, and to support that work, they provide us with much needed financial support. Thank you, patrons. On the next slide, I'd like to offer a very, very special thanks to Stanley Consultants, who are sponsors of today's webinars. Webinars are offered by the Academy after they've been vetted by a team of experts who offer feedback on the subject content to ensure that every webinar is of value to our members. Through generous financial sponsorship, today from Stanley, we're pleased to offer this webinar free to members of the Academy. Thank you, Stanley, for your support. And now on to our main event. Today, we have a fantastic presentation that crosses the borders of environmental engineering and science and other disciplines, all allied in our collective work to promote a healthy planet in the face of a changing climate. Colorado Springs has been working hard to improve its carbon portfolio, to decarbonize power generation. And today we're going to hear about how Stanley Consultants has been working to support Colorado Springs in their ambitions. As a little bit of background, let me share a little bit about Colorado Springs Utility. It's a municipally owned utility providing electric, natural gas, water, and wastewater services to the Pikes Peak region. As part of achieving their sustainable energy plan, Colorado Springs Utility is planning for 350 megawatts of natural gas, 525 megawatts of new solar, 625 megawatts of new wind, and over 300 megawatts of battery energy storage systems. I'm really excited to hear more about Colorado Springs Utilities and the efforts to implement an energy vision. Now, let me introduce our three speakers today. Phil Tennant joined Stanley Consultants in 2022 as Operations Director. Phil has a prior 33 years of industry experience, which helps him to lead projects as well as implement new recruitment, member development, communications, engagements, intern and young professionals programs, processes, and approaches. The second person we're going to hear from today is David Longree, who joined Colorado Springs Utilities in 2007. David has planned and delivered numerous water and energy projects. He's leading Colorado Springs Utilities' current battery energy storage projects and new resource acquisition. David's resource planning team performs electric and gas resource planning, distributed energy resource planning, and runs the demand-side management programs for Colorado Springs Utilities. And finally, we'll also be hearing from David Tennant, whose professional experience in the power industry dates back to 2015, when he started as a mechanical engineer with Stanley. David's experience includes design, feasibility analysis, owner's representative services, and construction support for new and existing power plants. Thank you to the three of you for taking time to join us for this webinar today. Phil, I believe we're going to begin with you, and then you folks will hand it off between each other until the end. The stage is yours. Welcome.
Yeah, thank you, Daniel. Yeah, appreciate that. And so welcome everyone. So really, this is where we've got an opportunity today to share with you one journey that a utility owner took to plan and transition its energy resources, from coal to other sources. So we initially thought, well, we'll call this a decarbonization story or a decarbonization of generation resources. But really, it's a glimpse into the implementing of an energy vision, and that's what we're pretty excited about to share today. So I get to sit between two Davids, and hopefully you can see and hear us okay. So David Longery is the manager of energy resources for planning and innovation for Colorado Springs Utilities. David Tennant is a senior engineer with Stanley Consultants that then helps on the implementation of projects such as the one that we're going to talk about today. So really it's a story of two companies as well. So I'm going to just focus on the two companies. I've had the privilege to work with both. And so that's why I was pretty excited to be able to, focus on this today. So let's start with Colorado Springs Utilities. So again, we're talking pretty much 100-year utility service provider and really a special utility service provider because it focuses on 4 services. So electric, gas, water, and wastewater. It's also a community-owned service provider. And roughly, just to put it into perspective, there's about 250,000 service points. So we're not even talking the population here, and a rapidly expanding service territory. It's one of the fastest growing areas in Colorado, an amazing place to live and recreate. But so matching the demand is a real challenging thing for Colorado Springs Utilities. At the same time, we've got Stanley Consultants, another 100-year member-owned engineering firm providing solutions to clients in water, energy, transportation, federal, really looking at that whole life cycle of delivery services from project planning through to design, construction, and operations. So pretty exciting stuff. And as I say, I've had the privilege of working for both, have huge respect for how hard it is on this journey. I'm really kind of excited to share that with you and give you that oversight. So when we talked about how we could fill the time, obviously we could fill it with a lot of this story, but we're really going to go into it's kind of 3 acts, if you like, so three parts. We're going to start really with the 2020 energy vision. So this is when Colorado Springs Utilities embarked on how do we start on this journey. We're going to set an energy vision. And then we're going to take electric and gas, because those two services are so interlinked, and we're going to have an integrated resource plan. So you're going to hear the phrase IRP a fair bit. This is the resource plan that plans out the generation resources or the infrastructure that needs to go into place to provide those services. You're going to hear about how do you include the customer and the public involvement, and you're going to hear about this vision through to operation and the consideration of some pretty amazing factors such as rates, reliability, and the resource diversity. Then we're going to flip over to the other David, and we're going to talk about, there was one particular, the Martin Drake power plant. So you're going to hear the Drake generation. That's the oldest fossil fuel power generation plant in Colorado Springs, highly visible in the downtown area. and a key focus for the community. So it was one of the key parts of implementing the IRP. David Tennant's going to cover that on the second part. And then really, you're never done. So David Longery is going to help us with what happened in 2023 that meant the plan is always the plan till it changes. And so it then, how as engineers, we have to remain, very focused on being adaptable. And so really with this, I'm gonna hand off to David Longery, who's going to take us on the first part of that journey, so this 2020 energy vision.
Well, thank you, Phil. Again, my name is David Longery, and so my teams do all of the electric and gas planning for Colorado Springs Utilities, really looking to the future on how we are going to generate electricity in the future and procure the natural gas to be able to sell to our customers. So to continue the framework around Colorado Springs Utilities, give you kind of the scale of our service territory. You can see we have almost 4,000 miles of power lines that supply the electricity from parts of our city to other parts of our city or outside of our service territory into our service territory. We have about 54 substations, and those are the stations that transmit or help the transmission system change voltage so we can carry the electricity for further distances without losing some of the electricity along the way. We also have 7 generation plants currently, and as you'll see through this conversation today, that number is going to expand as we're bringing on more and more generation. The number of plants that we're going to own and operate are going to change over time. And then Phil mentioned this earlier, we have about 250,000 service points. So and continuing to grow our service territory, and that includes more service points, but also our geographic diversity is changing a lot. And all that is taken into consideration as we plan. We're a regulated industry by providing electricity. And so the Federal Energy Regulatory Commission, or FERC, oversees our reliability. And we pride ourselves on that great reliability. As you can see, we have a 99.99% reliable service. And also our average interruption duration is 36 minutes. And that's a great number in our industry. We're in the top tier of the least amount of outages and that shortest duration. So something, again, as we're planning, we want to make sure that we provide that reliable service to our customers. You can also see our megawatt capacity, our peak demand back in 2022 was 959, excuse me. But actually in 21, we set our all-time peak demand of 989 megawatts. So you can also see that our peak demand changes year to year based on our customer uses, weather, and other factors. So our planning efforts have to be able to adapt to the weather and how our customers use our service. So our changing planning landscape. So the industry has been pretty stable for many, many years, being able to provide that safe, reliable, and affordable service. And that's still our mission. But we're seeing a lot of changes in the industry, including a lot of environmental and regulatory requirements, more changes to how we generate electricity to ensure that we are not negatively impacting the environment. We're also seeing a need for increased resiliency. So we're having more extreme weather events. And so if we do have an issue with our system, we need to be able to bounce back as quick as possible to ensure that our customers have service as much as possible and keep that reliability rate high. We're also seeing our customers want additional choices. They're wanting to have different pricing structures. They're wanting to be generators through rooftop solar or batteries that they own. And so we need to be able to provide that choice for our customers. And then innovation, and we're going to talk a little bit about that today with the units that we installed down at Drake, leveraging what new technologies out there, or even proven technologies in our cases, that we're now implementing into our system in ways that we've never done it before. So how can we leverage innovation to improve our services to our customers? And so all of this is really driven on requiring a clear vision. And so we need to know where we're going. What does that future state look like? And then that's incorporated into our integrated resource plan, which really helps define that 30-year vision, helps us plan to achieve that vision. And then also ongoing customer engagement. So again, we want to make sure we're listening to our customers. As Phil mentioned, we're a customer owned utility. We're a municipal utility. And so our customers are our owners. We want to make sure we're delivering services that they are asking for. So to set the stage for this, starting in 2019, 2020, we established our energy vision and implemented that through our integrated resource plans. And we'll talk about those two items a little bit more detail in the remaining part of the presentation. We're also looking at energy markets. And what these are is regional utilities are coming together to be able to buy and sell electricity with each other. And so we're able to leverage a larger footprint of not just Colorado Springs area, but potentially the West. So we can leverage other entities, generation facilities, transmission facilities. And this is really a great step to provide more cost-effective resources, as well as help us decarbonize our grid. And then grid modernization is a key factor as we plan moving forward. We're starting to see more physical attacks on our infrastructure, as well as cyber attacks. And we're having to address customers now becoming generators. The utility of the old, we were the generator. Our customers would consume that energy. But now our customers are also generating. So we need to make sure that our grid can support this two-way electricity flow, as well as protect it from additional threats that we haven't traditionally seen in the past. We're also looking at new rate designs. And so how do we sell electricity? Historically, for every electron you use, you pay the same price. Well, as we move into the future, it costs us a different amount of money to produce energy at different times of the day. And so we need to look at how we're charging for electricity to make sure that we recover our cost to produce that electricity, but also to ensure that our customers can afford our electric and gas services. And then we're looking at a new electric business model. A lot of what we're seeing from our customers is a requirement or a desire for additional services. They don't want just an electron or a gas molecule delivered. They're actually looking for additional services from us. So how do we change our business model to address and provide some of that customer service? And then finally, one of the big items we looked at in this planning effort was our plant decommissioning. So the Martin Drake power plant was the first power plant in Colorado Springs, and it was installed in the early 1900s and has continued to be expanded over time and improved and upgraded to date. And originally, we weren't planning to decommission that plant until sometimes in the 30s. And then Colorado passed some legislation and some carbon reduction goals that moved that plant retirement into roughly the 2026 timeframe. But through this planning effort, and a lot what David Tennant's going to be able to talk about today, is we were able to leverage this technology and shut down that coal power plant 3 years earlier in 2022. So David will be able to speak to how we were able to accomplish that early retirement of our coal plant. So our energy vision, Colorado Springs is governed by our city council, elected officials, and so they assigned a utility policy advisory committee made up of experts in the industry and local supporters to help us establish this vision. And I'll read this to you, but our vision is to provide resilient, reliable, and cost-effective energy that is environmentally sustainable, reduces our carbon footprint, and uses proven state-of-the-art technologies to enhance our quality of life for generations to come. So we really use this as our North Star to, as we plan, making sure that we're aligning everything that we're doing and implementing to that vision. And to help us narrow that down a little bit and be more clear on what that means, we established these 4 pillars. And the first one is economics. Understanding that we need to make sure we provide services that are cost effective for our customers, make sure that everybody can afford their utility bill. We're also looking to environmental impacts, making sure that we're reducing our carbon emissions by 80% by 2030, making sure we're meeting those goals that we have set for ourselves to ensure that we have or we're protecting the environment moving forward. We're also making sure that we have that resiliency. We're providing that reliable, resilient service to our customers because many people's lives depend on our services. A lot of manufacturing and businesses rely on us providing them reliable service. And so we need to make sure that that's a key parameter as we plan. And then innovation. And you can see we use proven state-of-the-art innovation and technologies. So what we're looking for there is how do we take technology that is improving, the new innovation that's out there, but that has been used before, and then apply it to us in an innovative way. How do we use it to best support our system? And that's really that kind of key item there is innovation, but in a way that enhances our system and can be used in our system. So part of this whole integrated resource plan process is we did it for our electric system and our gas system. As electric generation is becoming fueled by gas in certain circumstances, and we're seeing some regulatory drivers on our gas system to decrease use of gas and move that to an electric system, these two service lines need to be planned together. So part of this process, we divided into 3 phases. That first phase really talks about those inputs, assumptions, and sensitivities or potential changes to our plan to understand the impacts of that. We really spent a lot of time gathering that input, making sure that all those assumptions that we use in our planning are as accurate as possible. As we're trying to predict what's going to happen 5, 20, 30 years from now, that's a challenging task for us, but it's become critical that we start to better understand that. And for potential future engineers, one of the things that I'm really seeing in the industry is that need for data scientists to help us become more informed of what's going on in the past and how that's going to influence the change in the future. And how do we best forecast what's going to happen? And then our phase 2 is what we call the portfolio attribute process. So we modeled all of those inputs, we evaluate those, and then we understand the risks of each of those different portfolios, and we take all that information together to ultimately come up with a recommendation of the best portfolio of new resources. And this really then becomes that action plan of how are we going to accomplish our goals and what resources do we need to buy in order to get there. And so we'll talk a little bit more about that in the next few slides. So the input and assumptions. And so this is just a small list of the inputs and assumptions that we use in our planning models. And so a lot of those are forecasts. You'll see we are making the best estimates of what we think is going to happen based on historical information, as well as what's going to happen in the future, changes that we're seeing. And so being able to accurately predict all of these items that you see here and understand the potential changes is huge. And as we're making our decisions, because we are making billion-dollar decisions based on these forecasts. And one of the key inputs that's really been driving our entire effort is really around that environmental perspective and making sure that we're reducing our emissions to the targets that we had set. So in this slide, you can see that yellow line is our interim emission targets, which occur between 2023 and 2029, and then our 80% reduction of our emissions by 2030. And so on the 3 first bars you can see there, you can see that lowering to continuing to lower our emissions, and that's the decommissioning of Drake. As I mentioned before, through the units that David's going to talk about here in a few minutes, we were able to reduce our emissions rather quickly and ahead of schedule in order to by shutting down those coal units. And then as we progress along that line till we get to the 2029, we're shutting down our final coal plant, which is our Nixon power plant. And so once we retire, shut down that plant, we're able to hit that 80% reduction. And then moving forward, you'll notice in the rest of my presentation, we are adding additional natural gas generation, but by integrating renewables, by integrating natural gas, we're able to meet those carbon reduction requirements, but still maintain that cost effectiveness, affordability, and reliability of our system. So we took a lot of those inputs and those key drivers, and we needed to make a plan and a process to be able to figure out the priorities, because some of these are in conflict with each other or competing with each other. And so we need to figure out how we determine what's important to our community. And so starting in the left part of the graphic, we took a rating for each of the different portfolios, and then we multiplied that by the attribute weighting, which I'll talk about here in a minute. And then that came up with a score. And so this is a simple way to start figuring out which portfolio is potentially better than others, because the highest score is likely going to be your optimal portfolio. And so we went and did a big public process and brought a lot of people together to help us understand what those priorities are for our system. And as you can see, the highest priority for our system is reliability. And so that was weighted 32%, so the largest weighting. And that's really, how do we keep the lights on every day? And then the next two were tied. So equally important to our community was cost and implementation. Again, how much does that cost? And then how realistic is it to be able to implement a portfolio that we selected? And then that's 22%. And then environmental stewardship, again, how are we responding to reducing our carbon footprint and being supporting the quality of life of our customers? That was tied for second place as far as our priorities. And then you can see we drop off a little bit on flexibility and diversity. And that really is how well can we adjust to changing market conditions. And then finally, innovation. The community said, we want to still be looking at this innovation. How do we apply technology in a better way? But that was a lower priority for the community. So this really informed our planning efforts around what is important to our customers. So I mentioned our customers. Our customers are critical to how we do our planning. And so this diagram shows all the different entities that we've talked to throughout the planning process, doing a lot of workshops, doing a lot of surveys, especially to our residential customers, understanding that they can often have the biggest financial burden on changes that we make. And in the top there, you see the word quad. And this was a really fun partnership that we did with our one of the local universities in Colorado Springs, where students came and worked with us side by side, worked with different folks within the community to basically bring back feedback on our potential portfolios and our different resources and provide that informative planning ideas of saying, this is what our community wants. This is what we're hearing. And here's how Colorado Springs utilities can help implement this. So a great partnership with a local university, trying to get that customer voice. And so we take all of these parameters and we put them all together into a portfolio recommendation. And what I like about this slide is it shows that there are so many different things that go into our planning effort. Again, our customers, our stakeholders, the risks that are associated with each of those portfolios, the Utility Policy Advisory Committee, our board of directors, our employees were brought into this. Again, we have to look at what those financial implications are. And then the sensitivity results, I talked about this a little bit, but really that's if there is a change in our forecast or our assumption, how impactful is that on the portfolio? If something changes and we're not able to adapt to it quickly, that's a high risk portfolio. And we want to try to minimize all the risks that we have in these decisions that we're making 5, 10, 30 years from now. Again, we talked about the community feedback, survey results, and that attribute scoring and trying to use some qualitative and quantitative analysis to help us to make an informed decision on our portfolio. So that all ties together into these different pathways. And so on this diagram, this is just a sampling of the portfolios that we studied. And we broke them out into these different pathways because they're able to meet different carbon targets. They have different financial implications. And so you can see all the different pathways, but I want to highlight two of them. The very bottom one, pathway F, is where we looked at if we didn't do any new thermal generation, any new natural gas, any new fossil fuel generation, what would that look like? Only adding renewables. And so that would allow us to get to 100% carbon reduction by 2030, by 2040, and by 2050. And so we studied those. And what we found through this exercise is that the cost to implement that type of portfolio was extremely expensive. And so that became, as we looked at all the inputs, it became a heavy burden on our customers. And we were not able to meet that cost-effective affordability metric of our planning efforts. So what we did is balance that with pathway E, and you can see portfolio 17 specifically highlighted there, being a balance of adding some additional natural gas generation, and that's what David Tennant will talk about here in just a few minutes, adding that gas generation to help keep the costs lower and help to maintain that reliability that our customers expect. And then moving forward, adding additional non-carbon resources such as wind and solar and battery, and then really leveraging our demand side management programs, asking our customers to help reduce their usage will help us ultimately reduce our carbon emissions as well. So what that looks like between now and the end of the decade. So currently we have a 175 megawatt solar array that's being constructed. It's actually supposed to go online at the first quarter of 2024, so getting close there. And then we have 200 megawatts of battery energy storage that's underway. We're working through contracts with the hope that those battery systems will be brought online the first quarter of 2025. And then on top of that, we're adding the 525 megawatts of solar, an additional 100 megawatts of storage, 625 megawatts of wind, and an additional 350 megawatts of natural gas generation. And that natural gas generation is in addition to the generation that was installed at the Martin Drake power plant. And that's the type of resources that we feel that we're going to need in our future to help ensure that we have that reliability in our system. And with that, I wanted to pass over to David Tennant to be able to talk through how we implemented our first gas generation.
Sure thing, thanks. Hello, I'm David Tennant with Stanley Consultants. I was a part of the design team tasked with the design for implementing this gas generation at the existing Drake site. So I'm just going to go over a little bit of an overview of this project and some of the specific considerations around it. So we're going to show you just a before and after for the site, where this is located, some of the technology selection in terms of the units themselves that were used, a brief overview of the stakeholders and people involved in the project, and then mainly going over a lot of the constraints with either with the design or with execution or those types of parts for the project. Here's just a brief overview of the before and after the project. Before here on the left for the Martin Drake original site, and then here on the right after the project has been completed. So right there in the very center of the site, you can see the existing coal pile on the left one there. And just generally overview. So Colorado Springs is an hour south of Denver. The roads to the bottom and the left of these photos are I-25 and US Route 24. Very prominent location. So that was always in consideration for this type of project. This is also between that highway and the existing site. There is Fountain Creek, which was existing, which was of the utmost importance during design and the execution of the project to maintain. It's preserved and not affected. And then just overall, we're also at roughly 6,000 feet for the site elevation, 5,950, which can affect different aspects of the design. For this site, so the original site is coal generation. I believe there are 3 units there at the time. The previous early units had been demolished at this point. But the big change between those existing coal units and these new natural gas units would be roughly a 90 times less sulfur dioxide, SO2, roughly 5 times less nitrogen oxide, NOx, 50% less carbon dioxide produced per megawatt. And then overall for selecting this for Colorado Springs Utilities, that this would be the least carbon intensive fossil fuel option that they could go with. For the units themselves, the technology. So Colorado Springs Utilities worked with General Electric, GE, for their LM2500 plus G4 Express units. These are pre-assembled modules. I think it's roughly 10 modules in our case, that are heavily assembled and produced in the factory. I think they roughly say these are 95% factory assembled, as well as factory flushes to help in both the installation as well as just complexity of the support systems. These are aeroderivative packages, and in this case, for our site, we did dual fuel, so both natural gas and fuel oil, with fuel oil being the backup fuel source, not primary. This unit had dry low emissions DLE combustor, which allowed it to not have to have water injection to meet its emissions targets and guarantees. Another A big aspect of these specific units that were worked with is that they have an 8-minute quick start time to get to base load, that they can quickly meet the change in demand over the day as the megawatts that are required, especially near the end of the day. They have high efficiency, high reliability, high availability, and are just an in-between. So for the Express themselves, so in addition to being these modularized units, they have other units that could have been pursued, but these were definitely advantageous for both the timing of the project and that complexity, trying to make sure these were installed when power was needed. In terms of environmental, or in terms of the ambient temperature swings that this site's going to experience, it included with the package was an inlet cooling system. In terms of reliability, on your hottest days, if you're not conditioning the inlet air into your gas turbine, you're going to lose megawatts available from these units. And so with this inlet cooling system, which in this case was evap cooling, Colorado has a very dry, low humidity environment, which is well suited for evaporative cooling, spraying water into the inlet and evaporating to lower the temperature. And by doing that, you're going to get more dense air through the turbine, which will allow you to, through combustion, produce more megawatts. So this is a nice reliability on those hottest days, those really peak days that you need every megawatt you can get. On the other end, in terms of cold weather protection reliability, these units have an inlet heating system. So in this case, there's two big protections that you're providing for your low temperature situations. One is preventing icing on the actual gas turbine blades themselves. That icing can cause a lot of damage, and you don't want to lose that reliability during those times. As well as when the temperatures get too cold, the air gets so dense that you're now a very, very oxygen-rich combustion, which actually will affect your NOx emissions. And so in this case, we actually warm up the air just enough to make sure that we're not exceeding what our permit allows. So this system was an effective approach that we used on this project, which is basically injecting warmed air into the inlet by stealing the exhaust heat, the waste heat that's coming out of before it goes into the exhaust and out the stack. That's a nice efficient way of repurposing that heat that would otherwise be lost to the environment. And then in addition to that heat exchanger, which is off the exhaust, we have supplemental electric heating for those truly low temperatures, which almost all the time, those are never used. It's just those extreme weather events. And with those familiar with the February 2021 Texas freeze, low temperature protection on your gas turbine can be very important when weather events for the future may not look like your previous past. Some of the project stakeholders, just to kind of overview some of the major parties involved. Colorado Springs Utilities as the owner and operators. They're the ones actually making sure that it's available and online every day and that it's maintained. Stanley, we did the design effort, as well as we're there during construction to help support them, doing all the major disciplines: civil, structural, electrical, mechanical, which is my discipline. I'm a mechanical engineer, and then instrumentation and controls. And just a brief kind of overview of some of the systems and whatnot we did. So we have both fuels, the fuel gas and the fuel oil, as well as compressed air, the water for the evaporative system, as well as managing the drains, making sure that that's handled properly. And then one other large note is that for procurement, we have Colorado Springs Utilities procurement department listed here. Typically on a project, the very large equipment is for sure handled by the owner. In this case, because of the timing of all of this, pandemic had occurred, to which both lead times and costs were extremely uncertain and difficult during the early design part of this project, to where their procurement department provided support for lower priced items that maybe typically would have been covered by a general contractor, but they supported that to make sure that those lead times and costs were minimized for the project. So that was great support to the success. For some of the constraints of the project itself, so because the coal units were going to be decommissioned and our new plant positioned right next to it over the coal pile, we're using the existing substation, which provided a lot of saved cost, as well as you're getting the power where you need it when you need it. It's very easy to want, no one wants this power plant in their back doors normally, to where you usually want it outside of town. And in this case, you are making sure that you get power exactly where you need it with no additional infrastructure that would be a lot more cost and time to your project. So that was a consideration for when they were looking at these different pathways or options that they can, the speed and timing of the implementation of this project. The coal pile itself. So when you're trying to fit in a new power plant on an existing site, obviously we're working within limited area that is available. In our case, we worked with Colorado Springs Utilities to make sure that as the coal pile was slowly depleted, we had the geotech evaluations and soil borings completed kind of in a phased approach. We had the south end of site as that was taken away, initial evaluation there, initial foundation design supported around that with appropriate contingency. And then as moved to the north and eventually having to remove that equipment, we then verified our design was still acceptable for the soil conditions as we went further north. So you definitely need to make sure you're putting these on a nice foundation that's going to be able to handle the load. So this is a CAD overview of the site. In this case, north is to the left in the middle picture here, and highlighted the coal yard. To the south, we have existing high voltage lines, which are coming out of that existing substation. So that is a major consideration, both in terms of design, location relative to those lines, as well as construction, making sure that we're staying away and keeping appropriate clearances. Some additional parts of the undergrounds and considerations were some of the existing drainage for site crossed underneath the coal yard. And so when designing our foundations and locating equipment, we made sure to maintain those existing pipelines and not affecting existing drainage, storm or otherwise. And on the east side of the site, where the new gas line would be coming in from their existing tie point, we had to balance what was above versus below ground. There were some existing utilities where it made sense for us to be above ground for certain portions, and the parts that were below ground were treated with extra care to make sure that we're not hitting any of those. So for some of those digs, some hydrovacking was definitely used to make sure that we're not impacting any of those existing utilities.
Oops, did I skip one? I apologize.
Yeah, okay. Also, in terms of the procurement, actual equipment side of this, so for decommissioning the Drake existing coal plant and units, we were able to, which greatly helped the lead times for the project itself, we're able to reuse the large transformers for the existing plant. So here on the left are the units 6 and 7 GSUs, the generator step-up transformers. And then here on the right is located here at our new site. So of our 6 new gas turbines that were installed on site, 3 of them basically went through each transformer to where you have those 2 lineups for your site. And so not only the generator step-up transformers, but also the unit aux transformers, which are used to bring power into the plant to get you up and running for initial starts. And then we also had access to some additional either electrical equipment or other small equipment that helped save procurement cost for the project. improve lead time. In terms of redundancy, so when selecting these specific units, Colorado Springs Utilities originally had to decide, do we want one large unit? Do we want 6 modular small units? How do we want to handle this? And so with their smaller modular units, they wanted that flexibility for both the current requirements of what they need, as well as future. If for some reason they ever needed to relocate a unit, due to how the equipment is set up, it's much more favored to be able to do that than a traditional package that you might have. When we were designing the supplementary systems, so for natural gas, there are 6 gas compressors to get the natural gas to the correct pressure to the units. There are 6 of those to match the units, and they're sized such that if you take one away, the 5 gas compressors could still supply the full demand to those units. And then similarly for fuel oil, we did a similar approach with 6 fuel oil tanks, where if they ever needed to take a specific unit to relocate it as needed as they're implementing these other projects, they would have that option to do so. In terms of some of the emissions guarantees and environmental part of the actual combustion of these units, here are the GE guarantees that were involved for the project. So for fuel gas, with those DLE combustors, they were able to achieve 25 ppm as their guarantee. So they're going to make sure that they're under that, compensated for 15% O2. And then for fuel oil, 74 ppm, also compensated. At the conclusion of the project, they had their third-party emissions testers come in to confirm that they're meeting their permit requirements, and that GE was able to be successful on their emissions guarantees. Additional considerations for the exhaust emission side of that. For the CO here on the right, they have a CO catalyst in the exhaust to limit CO coming out of the exhaust or out of the stack. And then here on the left, they had pre-installed and saved space for if they ever needed an SCR in the future. So there were some considerations that were maybe low dollar value now, but they'd save a lot of money later, should ever an SCR be required to meet future emissions requirements. Some other things to overview for the project was just our fuel oil containment strategy. So how are we ensuring that no fuel oil is making its way into any drains or any locations that it really should not be. From unloading of the fuel trucks that are being delivered to site. In this case, we were using self-rising containment berms to handle the entire roughly 9,000 gallons that one of these trucks could ever spill. The storage tanks themselves, we have the 6 tanks here on the right. The middle portion of that is the tank itself, and the white part of it is a steel metal dike containment. So should there ever be a leak in one of the tanks, it'll go directly into that secondary containment, and be prevented from getting in any bad locations. And then just overall, generally for any location where piping or flanges or anything where you might have a small spill of fuel oil, all those foundations have raised concrete curbs to ensure that it can be handled properly and disposed of properly without going where you don't intend it to. And then lastly, we also have how the drains were handled. Each of the combustion turbine units have their own drains tanks to handle either fuel oil or water wash or different things that might come off the unit. And for those, we decided to go with this concrete precast pits approach, where in addition to these drains tanks being double wall, instead of burying them, we decided to put them in these accessible to operators pits, as well as so easy inspection, easy verification of no spills, and easy future, if they were ever to be relocated, ability to do that. This is just an overview of the project. You can see the mountains in the background, and fuel oil tanks on the left, units here, and each of the 6 stacks, and pipe rack there in the middle. This project wouldn't be successful without all the stakeholders working together to have a successful project for Colorado Springs Utilities and meet their power generation needs. Back to Dave Longry for where the plan has gone since this plant has been constructed.
Well, thanks. Yeah, I appreciate that. So, as Phil mentioned at the beginning of this, the planning never stops. And so, as these projects are being executed, we're continuing to look at changes in the industry. And as these plans were, or as these projects were being completed, some regulatory drivers changed. The state of Colorado made some updates to the Clean Energy Plan. And 2 key areas were around retail sales and market emissions. And so, when we originally did our planning, we were looking at all generation that we have counting towards our emission requirements. And the state clarified throughout our planning, or in the middle of our planning process, that we're only looking to track our retail sales, so what our customers use, not necessarily generation that we sell to a market. And tied to that market is we originally had planned that if we bought power from the market, there wouldn't be any emissions associated with those power purchases. But the state clarified in the middle of our planning effort that market emissions will be tracked, and so there will be a certain emission associated with any power that we do buy from the market. So that really changed on how we do our planning and then how we ultimately do meet our decarbonization goals. And also the clean heat plan was established, and this was on our natural gas system, and this focuses on decarbonizing the natural gas system. And I'll talk about that a little bit more, but as part of that whole clean heat plan and decarbonizing the system, there was building energy performance standards established. And so this is really large buildings, 50,000 square feet or greater in the state of Colorado, have to reduce their emissions, both on the electric side and the gas side. And so we're having to adjust our planning to recognize that there's going to be more potentially electric load from these larger customers as they're decarbonizing their gas systems and converting from gas furnaces, for example, to electric heat pumps. And then there's the new source performance standards for greenhouse gas emissions. And really, this is looking at, this is actually just in process right now, about when we build new gas generation or when we build new generation, each of those units have to meet new standards and more stringent standards moving forward. So as we progress with these new units that we're looking to procure, we're going to be under potentially additional requirements and constraints based on some of these changing laws. So still to come on that, and that can, again, reinforces that our planning process never ends, and we need to continue to be looking at what regulations are changing and what the industry is doing. But to dive into the clean heat plan just a little bit more, so this was passed in 2021, and between 24 and 25, the goal was to reduce greenhouse gas emissions by 4%. And this is from 2015 levels. So we not only have to get our emission levels back to what it was in 2015, and so overcoming that growth that we've seen on our system, then you reduce it another 4% on top of that. But part of this law also established a cost cap of 2% for those years. And really, this was to try to make sure we can protect our ratepayers, our citizens, from not being overly burdened with the cost to be able to try to meet these emissions. And then you can see between 26 and 30, we jumped up the reduction targets to 22%, again from that 2015 levels, but the cost cap went up to 2.5% for those same reasons, to try to make sure that the cost to hit these goals do not become where people cannot afford natural gas. And so on July 28th of this year, we submitted our clean heat plan in line with meeting those cost caps between now and the end of the decade to maximize the amount of reductions on our natural gas system, but only spending that 2% and 2.5% respectively, again, to minimize that rate impact. And so all of this comes together, and tying it back to that energy vision in those pillars, we were able to meet all of these pillars objectives. So we were able to check the box on the economic factors by integrating both natural gas and renewables into our system. We were able to keep costs low and be able to, again, protect our customers from overly high utility rates. We were able to check the box for environmental We are able to meet with this plan our 80% reduction by 2030 on our electric system. We're able to maintain that resiliency by, again, balancing with renewables and natural gas. We're able to ensure that when the sun's not shining and the wind's not blowing, our system is still able to operate and provide the critical services for our community. And then finally, able to hit that innovation box by what David talked about, by aiming to use these aeroderivatives, those jet engines, in a manner to provide us flexibility and to reliability, and be able to do that so quickly to be able to shut down Drake, our Martin Drake plant, even earlier. We're able to leverage that innovative technology within our system. And so we appreciate you participating in this webinar, and we look forward to answering your questions.
Very good.
Hey, fantastic. Man, I learned tons. That was awesome. That was absolutely awesome. So some of the questions that I've kind of got laid out that I saw from being put in the QA panel, as well as ones that I heard, let me just kind of lay these out, and then we'll come back and kind of walk through them. So I learned a new term today, IRP, the Integrated Resource Plan. So one of the questions is to talk about how do you integrate priorities for local, state, national, all the way through Department of Energy. You touched on this a little bit, but maybe if we can come back and talk a little bit about how you manage that dynamic changing environment to make those IRPs work. Second question is, in particular, when you were talking about the Colorado Springs energy vision, you had this what looked like an interesting set of terms, right? Proven state-of-the-art innovation. And I just thought, well, that's just kind of odd, right? Because how do you have proven state-of-the-art? So how do you, as a technical professional, balance the dynamics of being kind of cutting edge while having an emphasis from your stakeholders of reliability? Third kind of question, and you've touched on this some, but what's the unit of converting in your IRP? Like, how do you compare capital cost in dollars and O&M in dollars to environmental considerations? And how do you convert that into reliability? So you showed us in a decision matrix that you had some weights, but what's the units that are on those so that they all go in some kind of equation that makes sense? And in particular, one of the questions from the audience is that if you actually move from coal to natural gas to renewables, what are the rate increases that are expected? And how does this relate to environmental justice and people being able to afford stuff, and those that have less being cold in the wintertime because you've just priced them out of being able to keep their family warm? Next question was the issue of reliability. You talked about reliability being a big driver, but the question there is reliability related to generation, or is it also an awful lot about distribution? You know, is it that the generation goes down for reliability, or is it that the power lines get knocked down and that's where reliability comes from? So particularly as you move into localized kind of microgrid production from somebody's solar panel or wind turbine, and they want to pump it back or put it in batteries, how does reliability shift from the generation reliability to the distribution reliability, and how are you thinking about reliability there? Technical question. In particular, you're talking about these natural gas, lots of great details there and how they work, but it seems like there's an awful lot of preconditioning that needs to go in. Well, if it's too hot, we got to cool it down. If it's too cold, we got to warm it up. If it's too dry, if it's too wet. And so is natural gas actually a reliable generation approach across a variety of geographic areas, or is it somewhat limited? And an audience question here is there a practical way to increase the efficiency by installing maybe some heat recovery, steam generators, turbine exhaust? You know, what would be some of the ways to further increase the efficiency of those natural gas units? You talked a lot about integration. It was awesome. You talked about, well, okay, here's our fuel oil, and here's the secondary berms we've got so that we don't lose stuff into the environment. But the audience was really interested in understanding, in particular, the role of the water needed in the energy production and how that relates to the water utilities production of water. So, you know, are you getting water from the water utility and then additionally conditioning it on site? How is that working for the water you're using in that natural gas turbine system? And then kind of the last one to kind of round this out was the distribution system itself. So what kind of upgrades were required when using the existing switching stations, right? So how did you meet your specs and what were some of the new requirements for using the existing systems, but integrating in with the new? That was kind of a technical question. So that's the kind of questions that we had coming in from the audience. Maybe we'll go back up and kind of, you know, take those one by one, but now that you kind of know the flow of what we're going to talk about, feel free to kind of go a tangent or jump in as you want. If you want, you can kill the slide presentation because then smiling faces will come up bigger and it may make it easier for people to be able to kind of read body language as we talk through these. But maybe we'll go back up to the top and think about this IRP and what that means. If you could maybe address that to speak to the integration of priorities at state and local and utility, if you can help us understand that a little bit more.
Yeah, I wish it was an easy answer. I think that's the challenge of where the industry is going. Is there are a lot of competing priorities. Just quickly, the clean energy plan and the clean heat plan that I mentioned, which are just state policies, are a competing policies. So we need to decarbonize our natural gas system, which means we're going to move that load to the electric system. While in the electric system, we're trying to decarbonize it, but we're getting more load added from the natural gas system. And so that really is why we really tried to understand our own city's priorities to help us to better understand that. And then frankly, it's doing the best we can to understand where the legislation currently is at those three levels, at the the local, state, and then federal level, and then where are they going? They're constantly changing, and so we are constantly having to adapt to those. So I don't have a clear answer of this is how we've prioritized all those, but it really is. I mean, we have a team within Colorado Springs Utilities that is in Denver, is in Washington, pretty much constantly trying to understand where things are going, what's the intent, how do we help make those align. And then we're also, going back to those legislators and saying, this is what we're seeing from a utility standpoint and how the challenges that we're going to face. We meet with the state pretty frequently, just to stick to the kind of state level of, providing them data, providing them our perspective on these changes that you're suggesting. Here's how much that's going to cost. I know that's a question that we always get. Is the technology even available for us to be able to do this? And then how do we incorporate that into our existing system? So it's a lot of back and forth. And frankly, you do the best you can to meet all of those requirements, but at some time, we're a home rule city, meaning that we have some ability to control our own destiny. We then have to go to our city council and say, okay, here's these competing priorities. You city council, utilities board, same people. How do we respond to this? And here's the implications of those paths forward.
Awesome. Now I did notice when you were presenting, you said it. And by the way, future students, make sure you know how to support decisions and analyze data.
Yeah.
So.
Yeah.
Well, sorry, Daniel. I'll probably also, because I know the challenges. David does a fantastic job, and it's across all four services: so water, wastewater, gas, and electric. That David has a counterpart on the water and wastewater side, and their window. For the people in the audience, a utility owner has a window. How far out are you planning? You're probably 15, 20 years out is where you're trying. So that window is a rolling window.
Yep.
And then they are, looking heavily at bonding, borrowing, capital investment. Are we building new? Hey, let's make sure we're putting in the planning for maintaining the existing and the upgrades. And so I don't want his job. How about that, Daniel? It's a tricky job to balance, but I think an appreciation for that amongst the audience is, this is a challenge.
It is. It was great. I mean, it was fantastic because it's always nice to learn a new term, right? So if you work in the water space, maybe you don't know the energy space terms, or if you work in the energy space, you don't know the water space terms. So I really appreciated that. What's the unit that is used to pull all this? You know, like you had this nice kind of decision approach, and 32% this and 14%. But I mean, like, am I multiplying apples by 14% and oranges by 32%? I mean, what unit do you use in that kind of decision matrix?
Yeah, so we tried to make it as apples to apples. I wouldn't say it's perfect, but yeah, we tried to convert everything actually to a 1 to 5 score. And so all the criteria that went into that, and there's we probably should have showed that slide. We ended up taking it out because it got a little bit complicated, but it really, we took all those different parameters that make up, there's a bunch of sub parameters underneath that criteria we use. And we basically did a matrix to say, okay, if it falls between this range of cost or this operational ability. So for example, solar takes up a lot of land. So land was a consideration on overall stewardship. So a solar array is going to score lower in stewardship. So it may score a 1 because it's, megawatt output to acreage is huge compared to the units that David talked about, was we can get a lot of output for smaller. So we were able to bucket all of those parameters and put them into a 1 to 5 scoring. And then those would multiply then out times that attribute percentage. So we believe we were able to be pretty objective and transparent in how we got there, and bring things as close as we can when you're looking at hundreds of different characteristics of these projects to be able to give us an indicator. And we really used it as an indicator. This is what was recommended based on numbers, but then we used our engineering professional ability to say, what reality is, there's some other considerations that we need to factor into this. And that's where we ultimately landed, was using that input and then our judgment, and then making what we felt was the best for the community.
That's
Can I
tough.
add again?
Yeah,
Sorry,
go for it.
So again, for the people in the audience, there's a utility policy advisory committee that is a group of volunteers from the community that sit on a panel. So David and his staff will actually present a number of, hey, this is how we're thinking of doing the scoring on reliability or environmental stewardship. And they're getting input. So it's very much watching utility staff present to the community, and then a community policy advisory giving their opinion. So it really is quite a complex system to kind of feed in.
It's a lot to that. So let's drill into a little bit of some of these, technical questions that we also had from the audience, right? So folks got into the natural gas, and so it's kind of like, okay, great. Yeah, the water that's feeding into this, what does that do to the water utility? Is that such an insignificant amount that it really doesn't factor in, or does it actually have a big impact? What does that get treated before it gets discharged? Those were some of the questions. There's a whole idea of a turbine with the heat on the back end of that. So, help us understand those particular technical areas a little bit more, if you would.
Yep, absolutely. In terms of the water usage, it is actually pretty low to where I'm not sure internally how that worked on their side in terms of accounting for that cost. But it is a very, very low amount of water used for evaporation, as well as you don't actually have to do that to be able to produce. If they decide, for some reason the water is costly, or they are trying to limit that, they don't have to run them. So on that hot side, but on the cold side, so there's a couple things. So there's 2 reasons why you're heating up the inlet going into the turbine. The first one was protecting the blades, which that actually only occurs when the humidity is high enough to allow ice formation on them. So even if the temperature is low, it might not have any issue, because you might not have to do any of the heating, no additional loads on your turbine, just because you're not in the right conditions. So it's only a high humidity and low temperature for the blade portion. For the emissions compliance, so GE only guarantees down to 10 degrees F, but our site is going to get lower than that. So we have to, from a design standpoint, cover that range that GE won't guarantee. Now, the reality is they're going to guarantee a number that's different than what you're really going to get. So as they operate the units, they're going to see how low can we really get while staying within our permit before we even need to run this system. And you're always going to use the waste heat first. So the waste heat exchanger is actually roughly a 10-degree rise. So from 0 degrees to 10 degrees, you're covered by that that waste heat exchanger. And then from 0 degrees down to -20, you're covered by the electric heaters. So if you looked at how many hours a year are we within whichever windows, it is extremely small how often those electric heaters would ever run. If anything, they're just going to have the waste heat exchanger supply that heat to the inlet. And so there's a small fan that's pushing the new makeup air through that exhaust heat exchanger and into the inlet. So for the cold side of it, it's not going to ever be a very large parasitic load on the site. And we've had this exact same type of system installed in Alaska. So you can play around with how big that exhaust heat exchanger is. I'm pretty sure we did a 30-degree rise or something like that. So you just make a massive heat exchanger, collect as much of that waste heat as possible, and then have smaller electric heaters. It's whichever is more to you. Is the operating cost of running the electric heaters worse, or do you want to buy a larger heat exchanger?
Makes sense. And how about the air permitting on that back end? Is that something that Stanley did, utility did? Where
So these units have a SEMS, which is constantly collecting data on what is currently in the exhaust and always confirming that versus what the permit allows.
Makes sense.
Yeah. I don't know if we have time to dive into this. I was going to add a little bit more on the water. Well, so the water. So
get into it and tell us, because we've got an audience of technical folks that are excited to hear. So yeah,
but hopefully we're not that technical. But we're also the water utility. So unfortunately, on the water, going back to the water question, the Drake power plant was running off of our non-potable system, and is actually one of our largest users of that system. So we actually saw a revenue decrease on our water side, but we saw a cost savings on the electric side. But how we were able to leverage that is, as a growing city, we need more water. And so we're actually able to leverage that lower, by having that additional not potable water, we're able to leverage that for additional growth. So it actually worked out well for both services to be able to leverage that. And as David said, it's such a minimal use now, it doesn't really have an impact on our system. And I kind of heard into that question on the back end of these generators, potentially putting in a HRSG, the heat recovery, whatever the SG stands for. But part of the issue when these units become a combined cycle is their ramping ability. So that ability to move up and down decreases. And so the mission of these units for us is really that renewable integration. And so we're really concerned when the sun drops really quickly, these units can ramp with that. That's a bigger driver and priority for us than the efficiency. So we're willing to give some efficiencies on its heat rate and its ability to produce power in order to be able to operate at a much faster speed. So hopefully that helps a little bit with those questions.
This would be a little bit more in the peak rather than the base in terms of where you're expecting them to respond. They're there to quickly respond as you're getting shifts. That's part of how you're envisioning their operation.
Correct.
Yeah, makes sense. We had a late breaking question that popped in, and Phil, if you wanted to comment on the one we had just talked, but one that just came in, how about dealing with coal ash? Awesome, you're able to shift out of a plant and do some, but there must be some decommissioning that's going on there. And so is there a coal ash pond, and how is that? I know it wasn't in the presentation, but it came in from some of the audience. If you had the ability to speak to that, I'm sure folks are kind of curious what's going on with that.
Oh yeah,
so a couple of things. So we have a site down south of Colorado Springs that we haul a lot of our fly ash to, and the remains of the coal pile. We burned a lot of it. The site right now is capped, and so there are still things underneath the ground, underneath these generating units. And so, long-term use of that site is going to have to be evaluated based on, there are still some of those remnants of the coal facility down there. And then we do have the facility south that, is regulated, and that's where we try to move as much of our waste products and then cap that per the regulatory requirements.
Yeah. But yeah, there's not an ash pond on site. There were no, from our end, there weren't any of those type of considerations of being careful to not impact that type of pond and accidental release to the creek. That thankfully was not a part of this project.
Knock on wood, you didn't have to.
Yeah,
do it.
yeah.
No, this is great. One of the questions we like to ask folks when they're on here, because of course this is also, there are young professionals, including students, that watch these webinars, and many faculty use these in classes. So we always like to get from professionals' experience, next generation, right? What skills, what do they need to be able to be studying and learning to be able to feed into these kinds of projects? So if you've got any advice to speak to, those coming up behind, or the younger version of yourself, if only I had, what advice would you give people right now?
Do you want me to take
You
that
start.
a little?
Yeah,
Thank you. I think the appreciation for how much time and effort and energy it took when you see the journey, which is why we wanted to share this topic. We didn't want to just do a deep dive in, here's how we delivered a project. I think as a younger professional, if you can appreciate how the process works from end to end, and really we went from energy vision all the way through to delivery. One of those key steps that I didn't have appreciation for until I was working closely with Colorado Springs Utilities, that pathway evaluation. I know that the staff did a huge amount of consideration on, well, let's look at different options. I think in the engineering space, if you can have an appreciation for identifying the engineering problem and then really analyzing on, there are so many options, which is the best solution. That's what these guys just demonstrated, I think, beautifully. And I think an appreciation for that, not rushing to judgment, on, well, this must be the best solution. They really did a fantastic job.
Kind of in line with that, I would say this is probably the coolest industry to be in right now because it's changing so rapidly. So to me, the willingness and ability to learn, to ask questions, to dive into things, because the industry as a whole is learning. Nobody's been dealing with for 50 years 50-60% renewable penetration in their portfolio grid. Nobody's had years and years of experience of dealing with your customers now generating electricity and sending that back to you, and how do you have a two-way relationship now? So how you can dive into the new technology, dive into the new policy, business models, being able to learn, I think is the key of just keeping an open mindset and a learning mindset.
Yeah, and absolutely for me too is, for any of these systems, for instance, even the inlet heating system, for instance, there are multiple types of technologies you can use. You can have a boiler that supplies steam that heats up the inlet. Everything has a consideration and a pro and a con. It's never clean cut, as much as it would be nice to. But like even for like where we ended up, we said impacting performance on the engine was very important to us on that system. So other ones, which had a big heat exchanger to the inlet to the gas turbine, that's a large pressure drop going into the gas turbine, which actually equates to less power out. And so it's actually easier to have pressure drop on the exhaust of the gas turbine versus the inlet. So for our system, that was actually easier to go that route versus, so it's always, what is your priority and how do you get there using, everything costs money too. You have to work with vendors and find out what solutions actually work for your specific project.
Yeah, this was great. I tell you what, one of the things I learned was also coming more from a water standpoint, right, was that reliability was the one that was right up there, right? Of course, we expect reliability in water, but you don't see it quite the same way as you do in power, right? I mean, like somebody feels their power go off in their house. They don't know that maybe the quality of the water coming at the tap wasn't quite potable or not, right? You know what I'm saying? It doesn't quite, it's not an apples to apples comparison. So I love the emphasis on the reliability and then kind of wrapping everything around, a single item. So that was really inspirational. Dave, Colorado's, yes?
Oh, sorry, Daniel. I wondered if we if we circle back, you had mentioned
Yes, of course.
a question about proven state of the art.
Yeah, that would be great. Do you feel comfortable? I
Sorry.
didn't want to
Oh, yeah,
push,
no,
but I
we-
thought
Glad
that
you
was
brought that
there.
one up, Phil. Thanks.
Yeah. Well, no, because it is for the younger members. This was Colorado Springs Utilities is a community-owned utility, and that UPAC, that Utility Policy Advisory Committee, were very clear to David and his team. We don't want to be a testing ground for large technology, at the expense of our utility ratepayer, our utility owners. And so what's going to be interesting is, as David says, as the industry changes, so someone has to go first. And keeping up with a lot of this technology is it's who's going to take some of that risk in the industry, and keeping up with it such that someone like Colorado Springs Utilities can make that step into other technologies, I think is a fascinating place to be right now in the industry.
No, it's awesome. So I was gonna kind of give you the pass if you wanted, but I would love to hear more about it. So I mean, what I can just imagine folks sitting around brainstorming proven state of the art, and you're kind of like, okay, well, and innovation checkbox at the same time. That must have been a very interesting couple of meetings when you had those discussions.
Yeah, and I think the way it's worded really defines the conflict that we were going through. But I actually think these LM2500s are a good example of how I try to explain this. Jet engines have been around for a long time. They are a proven technology. Even these units have been implemented before. I wouldn't say they've been around for 100 years, but they have been implemented before. And so it is, but it's also very new for the electric industry to be relying on these for peaking units in generation. And so I would say that it's a fairly proven technology in a jet engine, but it's being applied in the state of the art way is how do I best use that innovative technology and how it applies to our system. And I have innovation in my title, not that we're a research and development company. I fought for this because I think this is so important for us, but not that we're an R&D company. But I hope that we're right there pushing the R&D. We're saying, hey, we need a solution. Water has reservoirs, so that's why your reliability is strong, because you can put a reservoir there to store it. We don't have that ability with electricity. Batteries are getting there, but so we need to be pushing the industry and saying, hey, we have this need for something to be able to store electricity for a long amount of time, to be able to supply electricity in those hours where wind and solar aren't working. And so I kind of look at that as us pushing that with innovation of saying, here's our need. How do you help us accomplish our goals?
Well, I think, don't they have in this technology penetration curve, and don't they call it lunatic fringe, early adopters and laggards? So you want to be in the early adopter space is what I'm hearing you say.
That's where I think we're going to have to be. Otherwise you fall behind so quickly.
Oh, that's fantastic. Well, this has been an absolutely exceptional webinar. I've learned a ton. I'm sure our members have learned a ton. Once again, David in Colorado Springs, thank you so much. And David and Phil, thanks to Stanley for sponsoring this and giving the American Academy of Environmental Engineers and Scientists opportunity to learn something about what's going on in Colorado Springs and the utilities. Thank you for taking time out of a busy day to be able to meet with us today. We really appreciate you.
Thank you for having us.
Thank you.
Over to you, Marissa.
Okay, fantastic. Thanks everyone for all your questions, and thank you to our speakers for sharing your knowledge with us today. If you have additional questions on this topic, please reach out to me and I'd be happy to put you in touch. We do have several webinars planned in the near future, so you can go to aaees.org/events and you can reserve your spot there. And just a reminder, if you're not yet an AAES member and you're considering joining the Academy, please email me and we can discuss our membership options. Last but not least, our PDH certificates for this event will be sent out this week. That's all for now. We enjoyed being with you all today. Thank you so much and have a great day.
Thank you.